Hello students, the topic is matrix chain multiplication. So, in this lecture we will discuss that what is matrix chain multiplication, what is the condition to multiply two matrices and then get the final result. And we will also find the time complexity for the matrix chain multiplication. For instance, let's suppose we are having two matrices. If I take the matrices from the problem given here in the question to us, A and B matrix. So the condition for the multiplication of the matrices is that the number of columns must be equal to the number of rows of the second matrix. So just in this case we can multiply both the matrices and get the results of as a third matrix. So here if I'm having 3 columns and 3 rows, then the condition is fulfilling, I can multiply them. But how many multiplications I have to make to get the results or to get the third matrix? Now see, here we are having rows and column as equal 7 into 3, 21, 7 into 3 into 5. So we will get the result as 105. So I will have to make 105 multiplications in order to get the third matrix. I will multiply A matrix with B matrix in order to get the C matrix, in order to get the third matrix, right? But the number of multiplications I will have to do, that multiplications will be equal to 105. I will explain it more a bit to you. Let's see. In order to multiply one matrix with another, we multiply the rows with the columns. So here if this one row is having 4 elements and that column will also be having 4 elements, so we will multiply each element with the other row. So I will have to make 8 multiplication just in order to get the single value of the third matrix. So this will be a very lengthy process if we do so this. Now we will come to the problem given to us. Here we are having 4 matrices A, B, C, D. So how are we going to multiply them that we get the minimum cost of the matrix chain multiplication? Is there any greedy method or greedy approach? Yes, there can be a greedy method or greedy approach, but here we have to multiply them using the dynamic programming. See, the problem is not to multiply the matrices and get the answers. This is not the actual problem. The actual problem is that multiply the matrices in such a manner that we get the minimum cost of the matrix chain multiplication. So how are we going to do this? We are going to do this using the dynamic programming. We are going to solve the matrix chain multiplication using dynamic programming. As dynamic programming is a tabular method, so we will draw tables for it. As you see in our question, we are having in our problem in the number of rows. If we take a look at the first two matrices, the number of rows, the number of columns are equal to the number rows are equal to number of columns of the second. So the condition is fulfilled and we can multiply them. Then the second matrix columns and rows are also equal, so if we can multiply them. Then the third and fourth rows and columns are equal, so we can also multiply them. So all these matrices we can multiply them and get the results. Using the dynamic programming, we will use the tabular method. So how are we going to draw the tables? We are going to draw two tables like this. The first one we will mention as X and the second one we will mention as Y. You can give them any names of your own choice. That is your own choice. That is up to you. That does not matter. So see, these are the rows and these are the columns. We will multiply them one by one and get the results. And in this table, the y table, we will mention that A to B, the answer in the matrix X we got by the matrix, either by the matrix A, either by the matrix B, either by the C or by the matrix D. We will mention over here, right? So that is why we have drawn two tables over here. Now see, the multiplications A into A, B into B, C into C and D into D will gives us the 0. So the diagonals here will remain as 0 as the self multiplications of all the matrices A into A, B into B, C into C and D into D will remain as 0. So we will mention the diagonals here as 0, as you can see now here. Now we will move to the further multiplications, but remember one thing, that we will just solve the boxes above these zeros. All the boxes below these zeros, we do not have to solve them. We don't have any concern with them. We just have to fill the table above the zeros, above the diagonals. But we are going to fill it in the diagonal form. First A to B, then B to C, then C to D, then A to C, then B to D, and then in the final last one A to D. We are not going to fill it in the row manner or in a column manner like A to B, A to C, A to D. No, this is wrong. We are going to fill it in a diagonal manner, right? So how are we going to fill it and how are we going to multiply the matrices? We will multiply them like this. If we are going to find out or multiply the matrices, the first one, that is A to B, this one. So we will take X matrix A comma B, which means that we have to multiply the matrix A with the matrix B. So what are the dimensions of the matrix A? The dimensions are 7 into 3. And what are the dimensions of the matrix B? That are 3 into 5. So as this will remain as same in both, so we will take the multiplications as 7 into 3 into 5. This will give us 21. 21 into 5, 105. So when we multiply the matrix A with B, the answer we get is 105. We have to make 105 multiplications to get this multiplication done, 105, as we multiply the matrices A and B, and the answer we got is by the matrix A. So here we will write A into B, A, right? 105 there, and A to B, the answer we got is by the matrix A. So we will write A in the second table. Now we will find the next one, C. The next one we are having here is, I have told you that we will fill the table in the diagonal manner. So the next is B to C. We have to multiply the matrix B with C. So we will perform the multiplications X, B, comma C, which means that we have to multiply the matrix B with the matrix C. So what are the dimensions of the matrix B? The dimensions are 3 multiplied by into 5. And what are the dimensions of the matrix C? The dimensions are 5 into 4. So as the rows and columns are same, so we will take this one as ones. 3 into 5 into 4. This will give us 15. 15 into 4, 60. So the answer is 60. We will have to make 60 multiplication to get both the matrices multiplied. Now we will fill it in the table over here. B to C is 60, right? And again the next one in the diagonal is C to D. So we will perform the multiplications for that. X, C comma D, which means that we have to multiply matrix C with the matrix D. What are the dimensions of the matrix C? The dimensions of C are 5 into 4 and the dimensions of D are 4 into 4. So as the rows and columns are same, so we will take this 4 as ones. 5 into 4 into 4, 5 into 4 gives us 20, 20 into 4 gives us 80. So if we multiply the matrix C with D, the answer we get is 80. So we have to make 80 multiplication. So we'll write 80 over here, right? And now we are left with the next diagonal, that is A into C, x comma A into C. So see, first up till now we were having just two matrices. We were multiplying them and we were getting the answer simply. But now we are having, if we are going to find out the multiply the matrix A with the C, here in between we are having another matrix. So we will multiply the three matrices with each other. But how we will multiply them? We will take a pair of two, right, and multiply it with the third one. So how we are going to do this? We can either take two, there can be two possibilities. We can take a pair of B and C and then multiply the answer with A, or we can take the pair of A and B and then multiply the answer with matrix C, and we have to get the minimum one of that. So let's perform the multiplications. Now see here, if we are going to find out x A comma C, which means that we have to multiply the matrix A with C, there can be two possibilities. We can take a pair of the matrix B and the matrix C and then multiply the final result with the matrix A. The second possibility can be that we can take a pair of matrix A and matrix B and then multiply the results with the matrix C. And finally we have to take out the minimum one of both. So let's multiply them. If we go for the first possibility, taking the pair of B and C and multiplying the final result with the matrix A. So let's see what are the dimensions of the matrix A. The dimensions are 7 into 3. The dimensions of the matrix B are 3 into 5. And the dimensions of matrix C are 5 into 4. So it means that matrix A1 into A1, right, plus x B comma C, we have already found out this B comma C, plus now we have to multiply it overall, right? So here we will see that this 3 and this 5, as they are same, so we will take them for ones. 7 into 3 into 4. See, these are the B in multiply into C are 1. So we'll just take their corners, right? So 7 into 3 into 4, right? So now let's get the answers. If we multiply the matrix A with the A, so we get 0, as the self multiplication gives us the answer 0, plus x, x is the first table, B comma C. So what was the answer we got there? That is 60. 7 into 3, 21. 21 into 4 is 84. So when we add them, 0 plus 60 plus 84, we get 144. Now let us check the second possibility. The second possibility was that we have taken a pair of matrix A and B and then we multiplied the final result with the matrix C. So the dimensions of the matrix A are 7 into 3, the dimensions of matrix B are 3 into 5, and the dimensions of matrix C are 5 into 4. So we will again go back to the table X. We have already multiplied the matrix A and B, so we are having the answer of it. X A comma B means that multiplication of matrix A comma B gives us the answer, plus matrix C comma C, that we have to multiply the matrix C with itself. So C multiplies C and the self multiplication gives us the 0. Now as you can see that this is a whole one, A B is a whole multiplication. So we'll just take their corners. 7 into 5 and this 5 and 5 are same. 7 into 5 into 4. See, now we have already multiplied the matrix A and B. The answer was 105, and the self multiplication of the matrix C gives us the answer 0. And if we do this multiplication, 7 into 5, 35, 35 into 4, 140. Now if we add these, all these, 105 plus 0 plus 140, we get the answer 245, and with the first possibility we got the answer 144. So which one is the minimum now? 144 is the minimum. So in order to multiply the matrix A with C, the minimum matrix multiplication is, we take the pair of matrix B and C and then multiply it with the C. So now fill it in the table. X. Write 144 here. So we multiplied the matrix A with C. So which one give us the answer? That is A matrix. So we'll write A here, right? Now go for the next multiplication, that is B to D. As we are going in the diagonal one, so B to D, we have to multiply the matrix B with the matrix D. Let's perform the multiplications. X B comma D, right? So again, if we are multiplying the matrix B with the matrix D, we will be multiplying three matrices. See, B multiply D, we are having the matrix C in between. So there can be two possibilities. Either we take B on one side and multiply C matrix with the D matrix and then multiply the results. Or we multiply the matrix B with the matrix C. We take a pair of matrix B and C and then multiply the results with the matrix D. These two can be the possibilities, and then we have to perform the multiplications and take the minimum value. So let's perform the multiplications. So we are multiplying the matrix B with D. There can be two possibilities. The first possibility is that we have taken a pair of the matrix C and D, and then we are multiplying the results with the matrix B, right? So the dimensions of the matrix B are 3 into 5, the dimensions of matrix C are 5 into 4, and the dimensions of matrix D are 4 into 4. So let's multiply them. See here, the self multiplication X B comma B, right? It's a self multiplication, and we have already multiplied the matrix C and D. So we are having the results plus X C comma D. We are multiplying both the matrices, and now as a whole multiplication. See, this is a whole multiplication, so we'll just take their corner values. These rows and columns are same, so we will take them as ones. So 3 into 5 into 4. See, if we multiply the matrix B with the B, the self multiplication always give us the 0. Now we will go back to the X table, and as we have already multiplied the matrix C with the matrix D, so we are having the results of that. So when we multiplied both the matrices, the result was 80. Add it into the 0 plus. Now if we take the whole multiplication, that is 3 into 5 into 4, 3 into 5 into 15, 15 into 4 is 60. Sum all the values. 0 plus 80 plus 60 gives us 120. Right? So this is the answer of the one possibility in order to multiply the matrix B with the matrix D. Now move to the second possibility, that is we are taking a pair of the matrix B and C and then multiplying the result with the matrix D. See, the dimensions are of the matrix B 3 into 5, the dimensions of matrix C are 5 into 4, the dimensions of matrix D are 4 into 4. So if we take it as a whole, we are multiplying matrix B with the C. So X B comma C, we are multiplying both these matrices, plus M self multiplication D comma D, plus whole multiplication. See, this is a whole, so we will take just their corners 3 and 4. Here these 4 and 4 are same, so we will take their ones. 3 into 4 into 4. Now as we have already multiplied the matrix B with the C, so the result was 60. We have taken this value from our table X, plus multiplication of matrix D with itself, the matrix D, the self multiplication always gives us the answer 0, plus the whole multiplication. 3 plus 4, 12, 12 plus 4, 48. 60 plus 0 plus 48 gives us the answer 108. So as we have calculated the multiplied the first possibility, that was 120, and now the answer we got from the second possibility is 108. So which one is the minimum one? 108 is the minimum one, so we will take this value 108, right? Now we will fill it in the table. So we are multiplying the matrices B into D, right? So if we have written 108 here. Now which matrix has given us this answer? C. We have multiplied the B with the C, so the matrix C has given us the answer. So in the next table, that is Y table, if we multiply the matrix B with the D, the answer is given by the matrix C. Now we are left with only one multiplication, that is A to D, but this is the most complex multiplication. Here see, we are having two matrices in between, so there can be many possibilities. Let's see what are those possibilities and perform the multiplications. Let me explain it to you by the matrices first. See, we are having four matrices and we have to multiply them, not just in order to get the answer, but in order to get the minimum cost of the matrix chain multiplication. There can be three possibilities. We can take the first matrix A on one side, multiply these three, and then multiply the final result with the A. We can take these three matrices, that was the first possibility, taking A on one side, 3 on the other side. The second possibility can be that we can take the three matrices A, B, C on the left side and D matrix on the right side. Multiply these three matrices and then multiply the final result with the matrix D. This is the second possibility, right? There can be one another possibility, that is multiply A with B, take a pair of both, multiply C with D, take a pair of these two, and then multiply both the pairs. So these are the three possibilities in which we can multiply all the matrices. We can multiply A matrix with the D matrix. So how are we going to perform the calculations? Now we will move forward to the calculations, to the multiplications. I would say we are having a specific formula in order to multiply the matrix A with the matrix D, that is x A comma D, which means that we are multiplying the two matrices that are A and D, but the formula is that minimum, right? We have to take the minimum value from all the three possibilities. We have done the three forms of the parenthesization, we should say, it would be much better. So then we have to perform the multiplications and then we have to pick up the minimum value from that. So for the first possibility, if we have taken A on the one side and three matrices on the other side, so x A self multiplication and x B comma D, we are having the three matrices on the other side, right? So I will explain it to you from the problem. The multiplication we will perform, we are multiplying B with the D, so we will take 3, 4 and 4. See, we are multiplying the whole, so we will take the whole values 7 into 3 into 4, right? How we have got this multiplication 7 into 3 into 4? See, we have taken A on the one side and all these three matrices on the other side. So as this is one whole, so we'll just take their corners. As 3 and 3, the rows and columns are same, so we'll take them as for ones. So 7 into 3 into 4, this 7, this 3 and the last 4. Now we will go for the next possibility. We have taken A and B as a pair x a comma b, that we have multiplied the first matrix and the second matrix, plus x c comma d, then we have multiplied the matrix C with the D. So what is the possibility, or what is the parenthesization we have done here is that we have multiplied A matrix with the B and C matrix with the D, and we have made two pairs, and then we have multiplied the entire results. So as this is the whole and these two matrices are the multiplying as a whole, so we'll take just their corners. 7, this 5 and 5 will be same, so we'll take 7 multiply into 5 into 4. See, here we have taken as 7 into 5 into 4. So it is clear to you how we have taken this 7 into 5 into 4. We were just taking their corners, right? The next possibility is that we can keep all these three matrices to at the left side and D matrix to the other side. Were multiplying these three matrices as a whole and then multiplying it with the D matrix. This is the last possibility. So what will be the formula applying here? See, x a comma c, like we were having the three matrices on the one side, that is A matrix, B matrix and C matrix. So we have calculated all these. We have already multiplied the matrix A with the B with the C. So we have the answer of that. Plus on the other side we were having the matrix D only, the fourth matrix, right? So x d comma d, so this is the self multiplication of the matrix D. Now the whole multiplication, three matrices on the one side and the last D matrix on the other side. So how we got this 7 multiply 4 into 4? I will explain it to you. See, these three matrices are on the one side as a whole, so we'll just take their corners. 7 into 4 are their corners, and now this 4 and 4, as the rows and the columns are same, so we will take it for ones, right? 7 into 4 and this last corner is 4, right? So this is how we have taken the multiplications of the whole matrix. Now we will place the values. X a comma a self multiplication gives us 0. X b multiplication with the D matrix gives us 108, and this gives us 84. The next possibility, that is x a comma b multiplication of matrix A with the matrix B gives us 105. Then multiplication of the matrix C with the matrix D gives us 80, right? And 7 into 5 into 4 gives us 140. Come to the third possibility. Multiplication of A matrix with the C matrix gives us 144. Self multiplication of the matrix D gives us 0. 7 into 4 into 4 gives us 112. Add all the values in order to get a single value. So here you can see that we got the values as 192 for the first possibility, as A on the left side and all the three other matrices on the other side. 325 for the parenthesization, we were having A multiply with the B and C multiply with the D. So we were having two pairs of one pair of A matrix multiplied with the B matrix and the other pair of C matrix multiplied with the D matrix. 256, this value we got from the parenthesization of all the three matrices A, B, C on the left side and then the other matrix D on the other side. So which one is the minimum of them? 192. So we will take the minimum value, that is 192. Now let's fill it in the table here, 192. So which matrix has given us this value of multiplying the matrix A with the matrix D? See, we have taken the A matrix on the one side and the 3 matrix on the other side. So matrix A has given us the answer. Fill it in the second table, that A matrix has given us the answer. See, A to D multiplication, A. We have written A over here, that which means that matrix A has given us the answers. Now let us again discuss the possibilities of the parenthesization of multiplying all the matrices using dynamic programming. Either we can take the first matrix on the left side and other three matrices on the other side. We can multiply the first two matrices and then multiply the other two matrices and then multiply the results. The third possibility can be that take three matrices A, B, C on the left side and D on the other side and multiply the results. These are the three possibilities or the parenthesization we can do in order to get the minimum cost of the matrix chain multiplication using the dynamic programming. Now let us discuss the time complexity of matrix chain multiplication using the dynamic programming. The formula we will be using over here, that is n into n minus 1 divided by 2. This will give us the approximate answer, that is n square. So now if we will do multiplications as we are going multiple times multiplication, so we will be going for the n times. So n square into n gives us the n cube. So the time complexity will be big O of n cube. This will be the time complexity for the matrix chain multiplication. So this is how we can use the dynamic programming, the tabular method, in order to get the minimum cost of matrix chain multiplication. Let me again repeat. The problem is not to multiply all the matrices and just get the answers. The problem is that multiply the matrices in such a manner that we get the minimum cost of the matrix chain multiplication. How can we multiply them in such a manner? We can use the tabular form, the dynamic programming, as we just did. So this was all about matrix chain multiplication.